Hey Math 30-1. So getting into lesson 28, combinations. Okay, so a little bit of review. So last class we were talking about permutations, right? So in lesson 27. So just as a bit of review on that, let's say that we had like a race and we asked, okay, how many ways can the contestants finish first, second, and third, right? So if this is like first, second, and third. And let's say that there was like 20 people in the race, right? So 20 people. Okay, well, we've done a lot of this now. This would be, okay, well, you'd say, like, how many people can finish in the first position? Well, there'd be 20. And then in the second, 19. And then 18, right? And we talked about the different ways that we could write that. This would be the same thing as saying, of the 20 people, we're going to pick 3, right? So there's our permutation, okay? Now, really what a combination is let's say we just changed our question for a second and I say, okay, you know what? I actually don't care about first, second, and third. And I just said, okay, how many ways are there for the 20 people to get first, second, or third, right? Like I don't care about the order. It's just a group of them, right? So, or like maybe it would be worded in the top 3, right? That'd be probably the better way to word it. So how many ways can the contestants finish in the top 3? So now, why that changes things, right? Let's say that we had, just to put some names in there, let's say we had like Tom, Bill, and Harry finished in the top 3 positions there, right? Well, now that there's no longer a first, second, and third, I don't actually care about the order. So if you think about it, here is one permutation of that. Here is one example of how they could have placed. But if you think about it, it could have been that. And it also could have been, what is it? Here, what did I use again? T and B. So B and T, right? It could have been written like that. Like that could have been the situation. So what we have to do, maybe you're getting where I'm going here, is we have to get rid of all the different variations that these top 3 could actually place, right? Because we don't care about them. So that's where this comes in. So our new formula is Ncr for combination. And what it really is just how many permutations it is, and then dividing out the different ways that they could be arranged, right? So in this case, it can be arranged 3 factorial different ways. So we'd be dividing by 3 factorial in that case. Okay, so that's the idea. It's combinations, the order doesn't matter, and permutations, the order does matter. So you guys, when you're doing these questions, you're going to have to be, picking whether or not you're going to use a combination or a permutation when you do the questions, right? Okay, so anyway, combinations are denoted Ncr, right? Like N, just like the last time. So N would be like, of the 20 people, we're going to choose, I say choose, but it's combination. We're going to choose 3 in this case, right? So in the last case, if it was first, second, and third, it would have been 20P3. But if I don't care about the order, right, and I just say top 3, then that's going to be 20C3, right? It's like we pick 3 spots. Okay, so that's what this stands for. And then combinations are actually so common in math that they have their own like other notation, like a little simpler notation. I don't know if it's simpler or not, but you just write it like this, where it'd be of the 20 people, we're going to choose 3. It's like 20 over 3 in brackets. Okay, so that's just another way of writing it. Means exactly the same thing, though. Okay. Then, okay, as you get going here, though, right? So I said, well, it's really just a permutation, and then we're just dividing out the different ways it could be arranged. Well, if you simplify that down, we end up with this equation, right? And this equation is on your formula sheet, too. You'll see that there's actually both of those examples, right? Okay. So yeah, let's jump into some questions here. I think we'll be okay. So this question says there are 12 females and 18 males in the grade 12 class. The principal wishes to meet with a group. Group is a key word there. Lets me know we're probably talking about combinations. So wants to meet with a group of 5 students to discuss graduation. How many selections are possible? Okay, so in this case, right, they've given us how many females there are, and they've given us how many males there are. But in this question, it didn't restrict any of our selections to males or females or anything else. This just says how many are possible. So just people, right? I don't care who's male. I don't care who's female. There's 30, right? 12 plus 18. There's 30 people to choose from. So 30, and then we're going to choose, and then we want a group of 5. So 30 choose 5. All right, so then very similar to permutations, where we find our combinations is going to be under math, and then over to probability, and then NCR. Okay, and then I can just fill it in there. So that's going to be 30, and then use my over arrow, and then 5. Okay, so I know some people are probably frustrated because maybe it doesn't look quite like this. Here, I'll explain the other variations. So in the end here, you get 142,506. Okay, so just little variations on those things. Some of them, I think like the older TI 84s or even the TI 83s as well. When you hit that NCR button, it will actually show up on your calculator as NCR. So then you're like, but you don't have the option to actually put the numbers in. So what you do in that case is you would put in 30 first. So in your calculator, you would write in 30. And then go hit the NCR button, and it'll come up like this. So it'll be NCR. And then after that, you'd put 5. Oh, sorry, 30, not 3. 30. And then you'd hit the NCR, and then you'd hit 5. So it'd look like that. Now, if you're using a TI Inspire, and sorry, I don't have the TI Inspire on my computer here, but it's under math as well, I think. Yeah, I'm pretty sure it's under math there too. The same thing, you go to probability, but then the way it's written is NCR, and then you'd go bracket, and then it would be 30 comma 5, and it'd be written like that is equal to. And then when you do that, and then you're probably going to be wondering where your comma is. Bottom left on your calculator, you'll find that comma button. So, okay. So that's if you have a TI Inspire. It would be like that. All right, moving on. How many selections are possible if the group consists of 2 females and 3 males? All right, so now we have a restriction here, right? So in this case, we just have to do them one by one. So it'd be consists of 2 males and 3, or 2 females and 3 males. So let's look at how many females we have. So we have 12. So I'd say of the 12, we're going to choose 2. Okay, so that's the first situation. And then for the males, I've got of the 18 males, I'm going to choose 3. So this is an and condition, right? So we have 2 females and 3 males. So what operation should we use here? Adding or multiplying? Well, it's going to be multiplying, right? Because we multiply the number of ways. This really is like the fundamental counting principle. We've got this many ways for this many ways for this. We'd multiply those to get the total number of ways. Okay? Next one. One of the female students is named Brooklyn. How many 5-member selections consisting of Brooklyn, 1 other female, and 3 males are possible? Okay, so not any more difficult. We just have 3 now instead of 2. So let's just look at the first one. So for Brooklyn herself, we could say, okay, well, how many Brooklyns are there? There's 1 Brooklyn. So I could say, of the 1 Brooklyn, I'm going to choose 1 Brooklyn. Anybody know what that would come to? Well, really 1, right? There's only 1 way that can happen. There's only 1 way that I can choose Brooklyn, and that's to choose Brooklyn. Okay, but anyway, if we want to keep it consistent with the combination notation there, we can write it like that. And then I'd multiply that by the number, so for the other females there. So then that's going to be, well, how many females do I have left now after I've chose Brooklyn? Well, I only have 11 to choose from, and then we're going to choose 1 of those. Okay? So now, and while you're looking at that too, what would that come out as? Well, you can try it out, but that's got to be 11, right? If you have 11 people to choose from, and we're only choosing 1, well, then I have 11 to choose from, right? So just, yeah, don't overthink those ones. But then, okay, then we're going to multiply by what's left, so 3 males. Okay, so then that's just the same as last time. So of the 18 males, we're going to choose 3 of them. Okay, and then that would come out to 8,976. Okay. And then just for good measure, I just want to kind of get used to this too. Let's write it in the other notation. This all could have been written like this as well. It could have been written as 1, 1, right? That's the same thing, times 11, 1, times 18, 3. That both those notations are exactly the same, like they mean the same thing, right? They're just written different. So that's also 8,976. Okay. Okay, so as with permutations, combinations have restrictions, so watch out for the words at most or at least, right? So above we were multiplying. Kind of what I'm getting at here is we're gonna be adding here in a minute, right? Like adding different cases. So Josie is writing a math exam. The instructions say that she must answer a specified number of questions from each section. How many different sections of questions are possible if she must answer 2 of the 4 questions in part A and 3 of the 5 questions in part B? All right, so this is just a fundamental counting principle type of one, right? This is like saying I have 3 kinds of shirts and 4 kinds of pants. How many outfits are possible, right? So we just have, so for the first one, of the 4, we need 2 of the 4 in part A. Okay, so that's just, of the 4, we're going to choose 2. Okay? And again, why are we picking combinations instead of permutations? It's because the order doesn't matter here. Right? So it doesn't matter what, like if I answer 2 and 4 or 4 and 2. Actually, it was a bad example because those aren't numbers. Question number like 10 and 12 or 12 and 10, right? They're the same thing. So the order doesn't matter there. But anyway, we have an and restriction here, right? So it's saying this many in part A and 3 of 5 in part B. So we're going to be multiplying. Okay, and then just do the other part. So now 3 of the 5. So of the 5 questions, we're going to choose 3. And that would come out to 60. All right, so here's where things are going to change, though. So in this case, she must answer 2 of the 4 questions in part A and at least 4 of the 5 questions in part B. So in part B, she could answer 4, or she could answer all 5, right? There's like 2 different cases there, right? So that's going to be like an or condition. It's like, is she going to answer 4 or is she going to answer 5? So an or condition, we're going to be adding those different cases, right? So we just have 2 cases. We're going to do it for 4, we're going to do it for 5, and then we're going to add those together, right? So, all right, so let's do part A will be the same for both though, right? So we need 2 of the 4 questions from part A. So that's going to be 4C2 times, and then now I'm going to multiply it by the part B scenario with only 4 questions being answered. So in part B, there's going to be at least 4 of the 5. So of the 5 questions, we're going to choose 4 of them. Okay? So in this scenario, this would be 4 questions in part B. In B, I'll just say. Okay. Okay, so that's what that would come to. That's a number in the end, right? So that's a number of ways. And then I'm just going to add that to the other scenario. So the other scenario would still be in part A. I'm going to go 4C2, right? Of the 4, choosing 2. And then I'm going to multiply that by, well then in this case, I'm actually going to do all 5, right? So this will be of the 5, I'm going to choose all 5. Okay, so this would be 5 questions in B. All right, so then that's it. So then multiply or add those together after we multiply them. And we end up with, well, that would be the same thing as 30 plus 6. So that's 36. Okay, so again, just saying the same thing in here, right? Just be careful with certain terminology there. But we'll do some more below too. It's kind of the same stuff now. So quite common in figuring out, number of ways things can happen is using cards, right? So if you're not a card player, then kind of look through this. Here's some just standard facts about cards, right? So we've got 4 suits. We got spades, clubs, diamonds, and hearts. Each suit has 13 cards in it because there's 52 cards in the deck, so 52 divided by 4. 2 suits are black, 2 suits are red. Yeah, I think you guys will be all right. Just read through those if you're having a hard time with cards. But okay, so in a card game, 5 cards are dealt, given to each player. This is called the player's hand. So in how many ways can one such hand be dealt with 3 black cards and 2 red cards? All right, so first off here, we've got the word and. So I'm imagining here that I'm going to maybe multiplying, right? Multiplying those situations. And the other part here with cards, right? If I've got 5 cards here and it's saying be dealt 3 black cards and 2 red cards, if I was wondering whether or not we're going to be using combinations or permutations, right? I'm asking myself, does the order matter? And does the order matter here? Well, no, not really, right? I don't care if like the black cards I have are here, here, and here, or if the black cards are here, here, and here, right? That doesn't matter. Just either way, I have 3 black cards, okay? So step number 1, I'm using a combination because I don't care about the order, right? So, all right, so let's figure out. If we're looking at for 3 black cards, well, first off, I got to figure out how many black cards there are actually in the deck, right? So how many black cards are in the deck? Well, there's 52 cards in the deck, and half of them are black. So there's going to be 26, right? So there's 26 black cards. So of the 26 black cards, here, what I'm going to do? I'm going to be fancy here. I'll make this black. So of the 26 black cards, I'm going to choose 3 of them. Okay? And I'm going to multiply that by, of all the red cards, so again, there's going to be 26 red cards, I'm going to choose 2 of them. Okay, so in the end here, that just plugging that one in, you'd end up with 845,000 different ways that could happen. All right, how many ways can you be dealt, or sorry, how many ways can a hand be dealt with at least 3 black cards? All right, so the word at least implies that we're going to have this like scenario with 3 black cards, 4 black cards, and 5 black cards. Okay, so we just have to do it for all of those. So that's going to be 3 or 4 or 5, right? Is kind of what that's saying with at least. Okay, so let's start. So this will be of the 26 black cards. So of the 26 black cards, we're going to choose 3 of them. And we're going to multiply that by, of the 26 red cards, we're going to choose 2, right? So that's like scenario number 1. Here. So that's 3 black cards. Okay, and then we're going to add that to the next scenario. So the next scenario is going to be of the 26 black cards, we're going to choose 4. Okay, so now that kind of changes things though, right? So if we choose 4 of those, then now of the 26 red cards, how many do we have to choose from? Well, only 1, right? So it's going to be 26C1. Okay, so that's going to be, if we had 4 black cards, and then just add the last case, right? So then the last case would be of the 26 black cards, we're going to choose all 5. Okay, and then you can multiply that by, well, we can keep the pattern going. You don't really need to multiply by anything here, but I'll show you why. Of the 26 red cards, we're going to choose none of them. Well, okay, well, how many ways can that happen? Of the 26 red cards, we're going to choose 0. Well, there's only one way that can happen. We can choose none of them, right? So that's actually just equal to 1. So we didn't really need that last part, but if you want to keep it like a pattern, then that's fine. Okay, so then that would be for 5 black cards, right? Put it all in your calculator, and we get 1,299,480. In how many ways can a hand be dealt with at most 3 kings? All right, so at most. So if we've got, yeah, at most, then so now there's even more cases, right? We're going to have a case where we have none, or like no, or yeah, none. Or we'd have a case where we've got 1 king, or we've got 2 kings, or we've got 3 kings, right? So those are all of our scenarios. So really in the end here, I know that I'm going to be adding 1, 2, 3, 4 cases. All right, so let's start. So the very first one would be for no kings. So that would be 48, C5. Actually, you know what? I'm going to do it the other way too. That'd be 48, 5, right? Just in the other notation there. So that's the number of... Well, sorry, maybe I got ahead of myself. You know what I'll do here? Let's actually just write it out like with none too. So we'd say, of the 4 kings, we're going to choose none of them. Okay? So, well, how many ways can that happen? Well, 1, right? There's only 1 way I can choose none of them. So again, you didn't need to write this part, but I did for good measure here. Okay, I'm going to multiply that by... Well, everything else, right? So that's where that other number I just had written down came from. So I'm going to write, of the 48 other cards, we're going to choose all 5 of them. Okay, does that make sense, right? Because I've got no kings, so I had to go 52 minus 4 to get 48. All right, so that's none. And I'm going to add that to the next scenario where we'd say, okay, of the 4 kings, I'm going to choose 1 of them. And then if I do that, I'll say, okay, well then of the other 48 cards, we're going to choose, well, the rest, so 4. Okay, so that would be with 1. And then we're going to add that to the scenario where we said, okay, of the 4 kings, we're going to choose 2. So then that would be 48. And then now this would be 3. Okay, so that would be for 2 kings. And then one more, we'd have, of the 4 kings, we're going to choose 3 of them. And then multiply that by, of the rest of the cards, we're going to choose only 1 of them. Okay, so that would be with 3 kings. So now multiply all those together, or sorry, add those all together. And we get, what do we get? Oop. We get 2,598,912. Okay, so a lot of ways that can happen. Okay, one thing I want to show you guys though, we could have actually done this a lot simpler too, right? We could have done this using, remember in the last lesson there, using something called the indirect method. Okay, so let's do it that way. The indirect method would say, okay, well, why don't we do it the other way? Why don't we just take the situation where we have all possibilities, okay, all possibilities minus, well, what would that be? So if it's at most 3 kings, right, then we could subtract the situation where we had 4 kings, like all 4 kings, right? Because that would be all of them. That'd be the only other situation I could have. So 4 kings. Okay, so if we're going to do that, all possibilities here would just be of all the cards, so of the whole deck, 52 cards, choosing 5 of them. Right, that'd be every, like I don't care about any restrictions, nothing else, that's just total cards. And then subtract the situation where we had of the 4 kings, we're going to choose all 4 of them, multiplied by, of the 48 cards left, we choose 1 of them. So if you do that, you end up getting the same answer. That would also be 2,598,912. Okay, so this one was a lot easier in the end, right? There was a lot less writing. Because, yeah, well, and even this expression, right? 4C4, well, that was just 1. And 48C1, well, that was just 48. So that did make it a lot easier, right? In the end, we could have just written 52C5 minus 48. So, all right, into the next stuff. So now, just like in permutations in the last lesson there, we're able to solve algebraic equations and simplify expressions. So if we had a situation like this, right, this looks like a bunch of nonsense, but we can write this out in factorial notation, and then we should be able to cancel a few things and actually simplify it down, right? So if we do that, we would say, well, you know what I'm going to do first, though? Let's write out what the formulas for these were again, right? So NCR was NCR is equal to n factorial over n minus r factorial times r factorial. All right, so that is on your formula sheet, right? So now we're just going to follow that pattern, right? So if I take n minus 1 C3, let's just do that part first, right? N minus 1 C3 would be, okay, well, that's like my n value in this, right? So on the top, I've got n minus 1 factorial. All right, that's like this. Over, and then it's, okay, well, it's supposed to be n, right? It's supposed to be n here, but remember, our n for this one is n minus 1. So that's what I'm going to write here. So I'm going to write this in square brackets there. So this, now this n value that I'm putting in, this is actually going to be n minus 1. Okay? And then I still have to go minus r. So in this case, it's going to be minus 3. Actually, you know what? Sorry, I'll make them round brackets. Okay? So hopefully that makes sense, right? This was our r value was 3. And then we just, and then it's factorial. And then the next step is just one more r. So that's going to be 3 factorial. All right, so that's what we've done there is that part now, right? Now let's do the other part. So the next part was times. And this is, well, 1 over, and then we'll do this one again, right? So now n minus 2 is like our n for the top, right? So that's going to be n minus 2 factorial over, and then on the bottom here, I've got, well, now it's the n part, right? So this will be n minus 2 minus r, which was 3. Okay, and it was all of that factorial. And then again, just 3 factorial, right? Just that, that last r there. Okay, this looks like a mess, right? So now we just have the task of cleaning this thing up a bit. So for the first one, it's looking okay. It's really just this part, right? I think we could clean this up, and then we'll have, like, you know, something like we did in the last unit where we can expand it out and then simplify. So I'm just going to write this again, just simplifying that first one. So this will be n minus 1 factorial over, and then this would just simplify down to, so n minus 1 minus 3 is just n minus 4 factorial. And then I've still got 3 factorial. Okay, so that looks better. Now times, now this part can look a little confusing. Let's just kind of remember what we're looking at here. This is like 1 over, let's say we had different numbers here. This is like 1 over 2 divided by 3 or something like that. Well, do you remember how dividing by a fraction is the same thing as multiplying by the reciprocal? That'd be the same thing as like 1 times 3 over 2. Okay? We can do the same thing, but so I'm not going to do that whole step. I can kind of see the pattern here that the bottom in the end is just going to flip up to the top when we do that step, right? Because you can imagine, here, maybe I'll put it in brackets. It's like we've got, sorry, I had to leave there, so I don't know where I was, what I was just saying. But anyway, I'm going to flip this one up to the top. So this will be, well, and I'm going to simplify in the same step here too. So this would be the same thing as n minus 5 factorial and then 3 factorial over n minus 2 factorial. So we're pretty set up now. Now we can start simplifying just like we did in the other lesson, right? So one that's kind of an easy pickings here would be our 3 factorial, right? I can just cancel those right now. And then, well, I'm going to have to expand, right? Like I have to get, like that's the only way we can get rid of these factorials is to expand them out. So I'm kind of looking at all of these ones, seeing, okay, if I start counting down, how do I turn one into the other, right? And what about this? N minus 1 factorial. Well, the next one down would be n minus 2, right? N minus 2. So that's pretty good one to start with. So I'm going to rewrite this top as n minus 1 times, and then n minus 2 factorial over, and then I'm going to leave the bottom for a second just so we can do one at a time here. So this will be n minus 4 factorial times, and then this was n minus 5 factorial over, and then n minus 2 factorial. So perfect. It's set up now that I can just cancel those guys out. All right, carrying on up here. Now what we have left is just n minus 1 over n minus 4 factorial still, times, and then n minus 5 factorial over 1 if you like, but whatever. All right, so now we'll just expand that out too, right? So which one do I expand out though? I'm going to expand this one out because the next one down would be n minus 5. So this would be n minus 1 over n minus 4 times n minus 5 factorial times n minus 5 factorial. So now these cancel. So all of that simplified down to n minus 1 over n minus 4. All right, next one. So now it says solve for n if 720, yeah, if that, right? Okay, so again, I can't really do much here until we actually put it into the equation, right? And actually get seeing what this thing actually looks like. So, all right, let's start. So we'd have 720 times, and then I'm going to have a bunch of stuff, right? So NC5 would really look like n factorial over n minus r factorial, so n minus 5 factorial, and then times 5 factorial, right, which is r. If you have trouble where I got that, just look at your formula sheet there. That's all just straight from the formula. Okay, and then that's equal to, and now just careful, this is a permutation, right? So the formula is a little different, but now this one's going to be n plus 1 factorial over, and then that's going to be n plus 1. Here, I'll put that in brackets like that too, minus r, so minus 5 really, right? So minus 5, and then factorial. Okay, so now simplifying that down a bit, yeah, I'll write it all again. So we've got 720 times n factorial over, actually, you know what, I'm going to write this too. Well, I'll leave it like that. So we've got n minus 5 factorial, 5 factorial equals n plus 1 factorial over, and then this will just be n minus 4 factorial. Okay, that was probably more work than it needed to be, but okay, so what we can do here, actually, you know what, in the last one here, what I should have done, I want to write it all again. So this 5 factorial, I could have called that, well, that's 5 times 4 times 3 times 2 times 1, right? I can write that out. That's actually just 120. Okay? And now can you see that I've got 720 over 120? They actually go into each other. If you cancel those, or if you just simplify that fraction, we can now write it again with another step as just 6, right? 720 divided by 120 would be 6 times n factorial over And now it's just n minus 5 factorial is equal to n plus 1 factorial over n minus 4 factorial. Okay, we're getting pretty ready, right? We're getting kind of set up so we can actually cancel these things. Now, we can actually kind of expand like a whole bunch of things out to try and make this work. There's different ways to do this. I think what I want to do though, right? Do you kind of see how we've got, you know, n minus 5 there, we've got n minus 4 there. Well, I'm going to get the n minus 5 and the n minus 4 over each other, just so, like, I think they'll cancel out a lot nicer. And then n and n plus 1, they're only one away, so I'm going to get them over each other, and I think we'll be able to cancel these nicer. Okay, so let's just rearrange that. So I'm just going to write the whole thing, but I'm going to bring the n minus 5 up and the n plus 1 down. Okay, so this will all be the same thing as n times 6 times n factorial over n plus 1 factorial is equal to n minus 5 factorial over n minus 4 factorial. So this is going to be nicer. Okay, so moving up here, well, I need to make these the same, right? I want to cancel some things. So 1 less than n would be n minus 1. So I don't want to really expand that one. I want to expand the bottom one, right? Because 1 less than that would just be n. Okay, so I'm going to write this again. It'll be 6 times n factorial over, and then this will be n plus 1 times, and then 1 less than that is just n. So I'm going to stop it there and say n factorial. Perfect. Those will cancel. Okay, and then moving over to the other side. Now this will be, okay, 1 less than n minus 4 is n minus 5, right? So I'm going to expand out the bottom. So we'll write this as n minus 5 factorial over, and then this will be n minus 4 times n minus 5 factorial. Perfect. I got lots of canceling I can do. So now the n's cancel, and my n minus 5 factorials cancel. And now we're back to just straightforward algebra, right? Now we've just got 6 over n plus 1 is equal to 1 over n minus 4. I'm going to just bring both of these up to the top to get them under the denominator. So now we've got 6 times n minus 4 is equal to n plus 1. So then 6n minus 24 is equal to n plus 1. So just getting things on the same side, we're going to end up with 5n is equal to 25. So n is equal to 5. Okay, last question. So this one says, at the end of a volleyball camp, each player shakes every other player's hand only once. If there were 276 handshakes in all, how many players attended the camp? Well, this definitely wouldn't be during COVID right now, but and we definitely wouldn't be shaking hands. But so this happened in the past, but let's figure out the question. So to kind of get a bearing on this one, well, I'm actually gonna do a little bit in reverse. Let's actually say that we knew that there were like 20 people in a room, and they shook hands with every other person, right? But only once. So in that case, that would be 20. So of the 20 people, we would choose 2 of them, right? Because that's the interaction. You got 2 people shaking hands. I don't care about the order, because if I shake your hand or you shake my hand, that's just one shaking of the hand, right? So that's why I'm using combinations here. So that's how I would figure out, you know, how many handshakes were actually made. Okay, so this question is just a little bit different. This one's saying, okay, we don't know how many people were there to begin with. So that's going to just stay as n. C, and then there are, two because we're shaking hands. And then they're saying that there were 276 handshakes in all. Right? So however many people there were to begin with, if they all shake hands, then there were this many handshakes in the end, right? So in this case, we're looking for n. So this is the same as above. So we're going to actually just expand this out to solve. So this would be the same thing as n factorial over, and then n minus 2 factorial times 2 factorial. And that's equal to 276. So 2 factorial is really, so 2 times 1, but that's really 2, right? So I'm going to multiply both sides by 2. So I get n, well, give me a minute. There we go. We get n factorial over n minus 2 factorial is equal to 552. Okay, and then I got to get rid of those factorials, right? So I got to expand this. So I'm going to expand the top so that I end up with n minus 1 and then n minus 2. So this will be n times n minus 1 times n minus 2. I'm going to stop it there. So I'm just going to say factorial over n minus 2 factorial is equal to 552. Good to cancel there. So cancel those. And we end up getting n times n minus 1 is equal to 552. And I think you guys are probably good from there, but I'll keep going. So we'll expand that out. We get n squared minus n minus 552 is equal to 0. Okay, and then the end here, if you factor this, you end up getting n minus 24 times n plus 23 is equal to 0. So my answers would be n is equal to 24 and n is equal to negative 23. But remember from above, we only want natural numbers, right? This won't make any sense to have an n value, like a negative n value. So this is an extraneous solution, right? That one doesn't actually give us a solution. So then say like therefore n is equal to 24.